In this lesson, you will solve equations for given variables, and you will use formulas to solve real-world problems. So, a literal equation is a formula or equation with several variables. What we'll be doing today is you'll have more than one variable and you're solving for one of them. Dimensional analysis is the process of carrying units throughout a computation. So if we're working with inches, we have to change everything to inches so that we end up with inches at the end. Unit analysis is the process of including units of measurement when computing. Let's start with the solving for a specific variable. In this equation, 4m minus 3n equals 8, we want to solve for m. So I'm going to go ahead and just circle the m. My goal is to get this m by itself. So what I'm going to do is this is 3n that's subtracted here. This is a subtraction. So I'm going to do the opposite, which is add 3n. So now on this side, I have 4m is equal to 3n plus 8. And you could say 8 plus 3n. The order doesn't matter. I just chose to put the n first. That's just me. Now my goal is to get m by itself. I'm almost there. Right now it's being multiplied by 4. So I do the inverse or opposite, which is divide by 4. And I'm left with m equals 3n plus 8 all over 4. Now, we could only divide if this is divisible by 4, this is, but this is not. So therefore, you cannot separate this. If you wanted to separate it, it would look like this, 3/4 n plus 2, because you divide this, you get a fraction, you divide this, you get a whole number. So either of these would be acceptable to me. If you can't simplify it all in one shot, you're going to have to simplify it piece by piece. Let's try this example. I want to solve for t. I'm going to go ahead and just circle the t. That's what I'm trying to get by itself. Look at this. All of this, r plus 4, is being multiplied by t. So let's just do the inverse right away and divide by all of that r plus 4. So now you're left with 28 is over r plus 4 is equal to t. And we're done. We have t by itself. Once again, if you wanted to separate this out, you would have 28 over r plus 28 divided by 4, which is 7. If you wanted to separate out, you could, but you don't have to. This is totally fine here. Let's just do one more example. Now, this one is in your notes. So if you want to have your notes out and do example 1, the second problem, it's just like this one, okay? This problem has, I want to get k by itself, so I'm going to circle k. Do you see how this is all being divided by 5 first? So we have to get rid of that division by 5 first before I can even do anything with the 2. So what I'm going to do is I'm going to multiply by the inverse, which is 5. So you have k minus 2 now is equal to, I take 5 times 11j. Remember, my goal is to get k by itself. I'm almost there. This is a minus 2, so I add 2. And I have k is equal to 55j plus 2. This cannot be simplified because these are j's, these are not. My goal was to get k by itself, and I have. So now you try the other example in your notes. Now, what happens when we have variables on both sides? As you can see, I have an x here, and I have an x here, and I want to solve for x. Well, you're going to have to get them together. You have to. So I don't care if you move this over here, or if you move this over here. It doesn't matter, but you have to get the x's together. So I'm going to subtract xz. So now I have 3x minus xz. I wanted to put them together just because I want them together. Minus 2y equals 5. Now I've got a ways to go here. My goal is to get x by itself. Can't do that yet. I need to get rid of this minus 2y. Inverse of subtracting 2y is adding 2y. So I have now 3x minus xz equals 2y plus 5. I chose to do 2y plus 5. You could have 5 plus 2y, same thing. Now, I want to get x by itself. Do you see how these are both? There's an x multiplied in both. So I can do what's called factor. I can take an x out. So I'm going to have x out in front, and this is 3x divided by x, which is 3, minus xz divided by x, which is z, equals 2y plus 5. Now this is nice because I've got x by itself here. So to get rid of this whole thing, this 3 minus z, just like the example we did on the other slide, you can divide by that whole thing because it's being multiplied to the x, and so we divide this side as well. So I'm left with x equals 2y plus 5 over 3 minus z, and I would just keep it this way. I would not change a single thing. I would just leave it like this. How about this example? Q over here, Q over here. Get them together. I don't care if you go left or right, it doesn't matter. I'm going to subtract QR. So I have 6Q minus QR minus 18 equals T. My goal is to get Q by itself, but I got to get rid of this first, so I'm going to add 18. So I have 6Q minus QR equals T plus 18. Think about what that step's going to be now. This has a Q, this has a Q, right? So we're going to pull that out. It's called factoring. We're going to factor it out. So now we have this Q gone at 6 minus, we factor this Q out, R equals T plus 18. Now to get Q by itself, I'm going to divide by this whole 6 minus R, divide by this whole 6 minus R. So you have Q is equal to T plus 18 all over 6 minus R. And I would just leave it like this, completely simplified, just like this. All right, what about a real world? In circumference formula, what we have is any circumference, right here's the formula, is 2 times pi times radius. And this is to solve the formula for R. So if I want to get R by itself, this is multiplied, multiplied, so inverse would be divide. I'm going to divide by all of that 2 pi, so I can get rid of all of it and just have R is equal to circumference divided by 2 pi. So here's what we're going to do. If we know the circumference, we can just divide it by 2 pi, 2 times pi. And that would equal the radius. So let's try this example. Find the radius of one of the largest yo-yos with a circumference of 32.7 feet. So I'm going to put that in for circumference. We're going to divide that by 2 pi. And it was launched by a crane from a height of 189 feet. And so we're going to be able to divide this, and we will get the answer there. So you do the division, and it looks like it's about 5.2 feet. When you divide, you're going to have to do 2 times pi first, and you take 32.7 divided by the 6.28-ish, and to get this. So try that on your calculator to see if you agree. Now you have one real world problem you're going to do in your notes right now. The last thing we're going to do in this lesson is dimensional analysis. A 10K run is 10 kilometers long. 1 meter is 1.094 yards. And we're going to use dimensional analysis to find the length of the race in miles. So we use what's called the railroad method. I start with what I have, put it over 1, and my goal is to put what I want here, and I want to cancel what I have. So in this case, I have 10 kilometers. I put it over 1, and my goal is to get 2 miles. Well, I know that 1 mile is 1,760 yards. So what I'm going to have to do first is do a conversion to yards here and get my kilometers out of the way. And then I can go to miles because I know the yards in a mile. So our railroad is just going to be 3 sections long. So what do I know about kilometers and yards? Well, I know here that 1 meter is 1.094 yards. You could do that conversion. Or we could even put in here, if we wanted to, we could put in meters here so that we could cancel out here. And I'll go through this because I'm doing this kind of on the fly here, so I'll go through this to make this make sense. I want kilometers to meters so that I can use the meters to yards conversion here, and then I can use the yards to mile here. This is dimensional analysis, keeping your dimensions lined up so you have what you have at the beginning, which is kilometers, and we get the miles at the end. So kilometers to meters, there's 1,000 meters in 1 kilometer. There's 1 meter is 1.094 yards, and 1,760 yards in 1 mile. So if you will look here, these yards cancel, these meters cancel, these kilometers cancel. So you just have the numbers now. 10 times 1,000 times 1.094 times 1. All of that divided by 1,760. And you will get, type that into my calculator here, about 6.2. And your label is miles because that's the only label you have left. See, all the other labels have been canceled out. Now you have an example to do in your notes. I'll set the railroad up for you so then you can try to plug in and then you can practice that later.